Evening, everyone. Yeah, I think we're live. I think it's happening. Everyone is here. It's time to start another episode in the ongoing Carmont series, and it will be the last one. So we might go long. We might go long. Hello, everyone. Let me know how the sound balance is. You should be hearing me. I can see green lines on OBS in front of me, which is usually a good sign. Oh, episode 113. The Carmont derailment. Detailed look at the final report, part 4. This is the picture that's appearing at the start of the episode, but anyone who's coming back to this in the future, this is definitely going to get renamed, because I'm going to go back and actually think about what we've covered in each of these episodes and sort of make them, signpost them a little bit better. Anyway, I've got a slide for that later. Let's get on with it, shall we? So, I'm just going to just immediately start this with a content warning that this is going to contain descriptions and images from rail crashes, and the news will include that too. So yeah, it's nothing. It's not actually anything particularly graphic, but it's the sort of thing that can be quite triggering and upsetting for anyone who's been involved, or might find it very upsetting just thinking and hearing the descriptions of injuries and descriptions and pictures of damaged vehicles that can be quite triggering. So anyway, just a bit of a heads up, and I'm going to content warning again when we get into the thick of it as well. So before we go on with the news, we need to look at the Covert Stats. A very quick look at the stats, really. Just showing that, let's get the old scribbles up. Just showing that rail is reaching the point where it's reaching bus area. Actually, I've just scribbled over to the point where you can't see. It's kind of reaching the point of, weirdly, there's a single point here, which is where we have the last reliable stats, although they keep getting updated. And by the way, increased every time they get updated as well. But yeah, because there's some data from all the way back here that's been updated as well, and all of it's lifting the numbers. Weirdly, road and rail have dropped to meet, which is a bit strange. The same levels. Anyway, so road is at 100%. Bus has bounced back a bit, which is good. Rail is sitting around about the 80% mark. As Phil Haig kind of records these slightly differently. He's got his 28-day rolling average, which is now sitting at 80%. So rail is sitting around about the 80 to 85% mark, which is good. Yeah, that's good news. I'm surprised it's sitting where it is, but we'll keep watching timetables. When is the next time? Well, I suppose the new timetable was introduced. I'm surprised it's not resulted in a hit. We'll see anyway. Yeah. Let's as ever, we shall keep our eyes on this. I'm going to continue to include this within the episode as we go forwards, because I think it's important to. Until they stop publishing it, we'll keep looking at it. Anyway, right. Oh, yes.
To be fair, Transport for Ireland believes we all deserve our fair share of good news. Fair with our fans after big matches.
Puck fair party goats. And especially all the daily snails pacers.
Not fair. Which is why fares on buses, trains and trams across the Transport for Ireland network have been reduced by a fair whack. An average of 20%, in fact. Which makes it fair game for cleaner, greener, cheaper travel. So what are you waiting for? Let's get going fairly lively.
There you go. That is how you do advertising for public transport. Nice one, Transport for Ireland. Love that. Absolutely love it. Yes, big 20% fare drop on average across Ireland, and it's just this is what you should be doing, folks. This is how you do it. Good grief, this is how you do it. Yeah, I mean it's not necessarily it's not necessarily world shakingly cheap fares, but it's a slash of 20%. And they've already been trialing this on certain rail routes and other kind of routes, and it's been shown to result in a 10% leap in ridership, and quite a lot of where they introduced this fare drop, people are traveling by train as much as they were pre-COVID. So yes, this is how you do it. So I know that there are a lot of people who've worked very hard on. Well, anyway, okay, we'll get to the England sale momentarily. So that's Ireland. Scotland has also done a fare drop. It's by some measures smaller, by other measures larger, but it's unlike Ireland, who've just outright done it across the board and intend to keep it that way. Scotland are just doing another sale. So they're doing a sale, half-price ticket sale for off-peak only in Scotland. Okay, fine, but it's not quite as good as, let's face it, it's not a permanent reduction in the cost to travel, is it? So, yeah. So that's fine. Meanwhile, in England, there's whatever the Great British Rail Sale was, which, okay, they sold some tickets. They did some very bizarre stats in this little poster. These are very strange. The free takeaways thing, I don't even understand that statistic. They actually took it out of the press release. I know people have worked hard on this, and Ireland has got a much more simple, straightforward system. But that's how you do it. You just do an outright. That's how you do it. This is not how you do it. If you want to really make change, that's how you do it. Not this. It's very frustrating. And also, if you want to see what a nice, friendly, tongue-in-cheek advert looks like, Grant Shapps, it looks like how that advert was, not your patronising bumf. So anyway, yeah, there we go. Isn't it great to be in the United Kingdom? Bring on unification. That's all I'm saying. Meanwhile, while we put little sort of little advertising sales out, large sections of Britain's coast are going to be subsumed in water. Fairborn is probably the first village that will be completely obliterated by rising sea levels, because the Welsh government's decided to not bother to do anything about it, which is fair enough, because it would be incredibly costly for a very small population. What is it, like 600-700 people who can just move? So there's no point defending it, which I think possibly means that the little railway will also be obliterated. I can't remember where the little railway is, but I think that also will get obliterated. Feel free to correct me on that, everyone. Yes. So there you go. Marvellous. Oh yeah, the TSSA. That's it. It's my unit. Where's my card? There it is. Yeah, there it is. I'm not going to show you my number, but yeah, there they are. The Transport Salary Staffs Association. I'm waving around my members card. It's here. You can't see it because I haven't got a big face on. If I put my little face in the corner, look, there it is. Hooray! Yeah. TSSA is 125 years old this year. We're gonna have probably a couple of TSSA episodes going forward this year. I wasn't at the conference because I just didn't have the time to do that, and was juggling family and bits and pieces. So, but yeah, it was the conference has concluded. I think. I don't think today was yesterday the last day, or perhaps today's the last day of the conference. Yeah, 125 years of a union. It's not bad going. So yeah, Gareth Williams. Yes, that was Fairburn. Yeah. So, 125 years of TSSA. Stay tuned on that front. But hello to TSSA union folks, and also ignore all the union busting stuff that's going on, RMT folks, solidarity, etc. Right. It's 20 years since Potter's Bar, or it was yesterday, and to the day, and yesterday it was to the day anyway. This is an incident that ended the subcontracting of track maintenance for rail infrastructure in GB. It was brought back in-house. It was incorporated into the infrastructure manager who Railtrack collapsed in on itself. Network Rail took that up, and Network Rail announced in the aftermath of this in 2003 that they would take all. It was almost kind of as Network Rail were created, really. They would take all track maintenance in-house. In this case, it was Jarvis. In the case of Hatfield, it was Balfour BT. It was one of a sequence of miserable failures of the way that privatisation was set up, and it killed 7 people, 6 passengers and a pedestrian who was a lady who was underneath the bridge and got killed by falling masonry from the parapet of the bridge just south of, or at the end of the platform, as this thing barreled its way towards the platform canopy. Pretty appalling incident. It was as a result of an S&C splitting under the train. At some point, we might pick through the report and kind of go through in detail. But after the Carmont report, we'll perhaps leave detailed deep dives of rail incidents for a while, unless you want them. Patreon people, if you want more of this, then obviously tell me such. But anyway, 20 years since Potter's Bar, and it's interesting to think about the context of this and what we learned off the back of this. Whilst also, while government is pushing and forcing and squeezing Network Rail to reduce staff numbers and to generally kind of threaten the safety of the railway, Network Rail, because they have to, are going to say that that's not what's going to happen. given the feedback I'm getting from staff about overtime and recruitment freezes and that's often clerical roles, my sorts of roles, rather than frontline staff who are genuinely at the front line of keeping railways safe. And I know a few of them who are saying much the same thing. I don't see that the government's pressure is compatible with it, let alone the idea, even putting safety to one side. I make the case that the government is pressuring Network Rail and the railways to shrink at a time when they need to be expanding rapidly. The idea that then on top of that they're now threatening safety with pressure on Network Rail, reductions in staffing is really worrying. So yeah, this is that 365 in Network Southeast. It is, yeah. They hadn't rebranded it by 2002. So anyway, and that was 20 years ago. As we know with Carmont, this is relevant today, and indeed, thankfully this sunny side off derailment here. You can see the lovely. There's a lovely museum next door to where this derailment has happened. This didn't hurt anyone. It's an empty coaching stock move, and it looks like the points have. Something's happened with the points. I don't exactly know what's happened. Hopefully we'll find out exactly what's happened so we understand what it is and can ensure it hasn't happened again. But if a set of points is split again, then, yeah, I'll let you join the dots. And, this is why I gave a bit of a content warning. Yeah, there's been a fatal crash in Münchendorf. A rail crash. 2 people have died. I don't exactly know what's happened here. It looks awfully like a head-on collision on a single track section, but I don't want to jump to conclusions. But there's certainly been it's a pretty horrendous collision. Obviously the vehicle is very robust, but it's resulted in people 2 fatalities and additional serious injuries. So not good. Rail safety is critical. It's not just in the UK where safety is an issue. This continues to be an issue in lots of places. This is in Austria. Yes. So let us. Well, I'll put that back up there. Let us get on with the episode. And this is the last episode of the Carmont series for now, at least, unless something else comes out. And we are going to finally get around to. Not only are we going to look at the report, we're going to finish kind of our flick through the report, the detail in that. We're going to summarise it, go through and sort of summarise the results. We're gonna see, kind of review everything that we've learned, pick up a few points that I've captured. I think remind ourselves what we looked at in the earlier episodes, because we've had 4 of these and they're quite spread out. So we'll remind ourselves of all that stuff, and hopefully by the end of it we'll have captured a decent amount of useful learning for us to kind of recall, and there'll be some stuff that if any of us here are practicing in the industry, we can remind us of things we can assert ourselves on if we're receiving pressure for whatever it is, given current climate or both literally and metaphorically. So let's get on with it. Welcome to tonight's Rail Natter, everyone. As the Intercity 225 fades away, there's a few of you saying in the chat that it was actually just one train involved. Yeah, I don't know anything about the incident. I just had it flick up and thought I'd quickly grab it and pop it in the news. So I'm not so much speculating as just saying I don't know. Go and have a look at that incident. What official news there is about that incident if you want to read about it. The Münchendorf incident. So we've actually done. This will be the 5th Carmont episode if you include our look at the interim report, and I'm going to rename these and just sort of. Do a bit of rename each of them and sort of restructure so it's obvious. What each of these is. So the things that are in brackets, I'll probably put different words in there. And it's just so it's obvious what's going on for each episode, so you can follow them and find them easily and understand what's what. So yeah, I will do that. As I said earlier, there's the content warning for descriptions and images from rail crashes, including descriptions of injury. So if you don't like that, then turn off now. In audio only form, it's probably fine, but I'm going to be describing some things, and there are things, as ever, like with this, there are sections that I read out verbatim because it's kind of they're worded as concisely as they could be. So yeah, so that if you're getting frustrated with me reading things out verbatim, it's because I think they're important and I think it's relevant to just pick particular bits out, and we'll skip over other parts. So let's get back to the report, shall we? This is where we were. We were at. Can everyone see my mouse? Yeah, you can. It's coming through. Okay. So Jonas Geiswinkler is saying 1 casualty in Münchendorf, not 2. Oh, that's good. So yeah, the news report that I looked at said 2. So I'm pleased to be corrected, particularly as it's in terms of reducing the number of fatalities. So right, let's. I'm afraid we're really going to get into the thick of it because we were just at the start of the section on causes of injury, which means going through in detail of the injuries and because this is part of crash investigation. You look at all the evidence you can, including injuries, including whether it's post-mortems or just understanding the injuries of people who are on the train, because that teaches you. Not only does that give you information about what happened if you're not sure exactly the sequence of events, but also it allows you to understand where we can learn more about perhaps train interiors or where we position seats, whatever it might be, or the robustness of panes of glass, all these types of things. These reports allow us information about making the railway safer and better. So, the investigation analysed the physical injuries sustained by the passengers and staff on board the train to determine severity, likely causes, and any safety lessons that could be learned. Yeah, just like we said, right? The analysis has not attempted to capture or assess the degree of psychological trauma suffered by the survivors. Yeah, it's difficult to capture that in a report, and there's only so much you can learn, materially learn from that. Certainly in this type of technical report. So yeah, as I say, post-mortem statements from medical professionals who treated survivors and witness statements, as well as photographic evidence, inspection of the damaged vehicles, and reconstruction of vehicle movements during the derailment. So. And again, there's images here showing the damage. This is the leading end of coach A, which is the coach that was immediately behind the power car, as the power car was peeling off the bridge. Of the 9 people on the train, 3 suffered fatal injuries: the train driver, the conductor, and 1 passenger. A further 3 passengers suffered serious injuries. 3 others, including the conductor travelling as a passenger, suffered minor injuries. For those who suffered fatal and serious injuries, all of whom had multiple injuries, a more detailed analysis was carried out to grade each injury. This was done using the internationally recognised abbreviated injury scale scoring system. I'm going to bring my little face up. In this system, each injury is scored from 1 for a minor injury to 6 for an injury that is thought to be incompatible with life. Crikey, that's an unpleasant euphemism. Using these individual injury scores, an overall injury severity score was evaluated for each person. I've not come across this system before, actually. I haven't seen this used. I haven't actually seen this used in previous reports, or I don't remember being used in this way. Yes. So, the distribution of injuries on the train, location of occupants, injury severity scores, and likely primary cause of injury are summarised in Table 7. So we can go through and see that the leading power car. The driver's fatality was as a result of secondary impact with the cab's windscreen and interior. The conductor was killed by a loss of survival space in the leading vestibule. 2 serious injuries in coach D. Oh, actually, I was describing coach earlier. I showed a picture of coach A and said it was the one behind the power car. That's not correct. It was that was the coach at the back. Forgive me. Coach D was the coach at the front of the train. Both passengers who were seriously injured in Coach D, secondary impact with the vehicle interior, lacerations, and ejection from the vehicle near the end of its travel. It's just, you do not want to be fired from a train, ejected from a train while it's rolling around. That really is a failure again. And HSTs have been commenting on this. The glass is not, up to standard in terms of keeping people within the train. There's a passenger in the leading vestibule of the Coach C who was ejected from the vehicle and then impacted with terrain, and then there's a passenger in the trailing so then other passengers, there's a serious injury of secondary impact with the vehicle interior, and then 2 other minor injuries with impact with the vehicle interiors, and then the minor injury of the conductor injured themselves during egress of the train at Coach A. So that gives you an idea of the sorts of injuries, and you can understand the forces involved. Huge forces involved in this incident. The loss of survival space, ejection of the passengers through the open gangway at the leading end of Coach C was probably when it struck the wooded bank. And the primary cause of serious injury to 3 of the survivors was secondary impact with vehicle interiors. 2 passengers were seated in forward-facing seats and 1 was in a rearward-facing seat. Both coaches C and D underwent extreme movements and rolled over onto their roofs before they came to rest. These movements would have subjected passengers to accelerations in the vertical, lateral, and longitudinal directions. So that's kind of giving an idea of the movement of the sort of experience that passengers would have had in these in the trains. The 2 survivors in Coach D also received multiple cuts and lacerations from broken glass of the windows. Medical experts assisting the investigation considered that the shards of broken glass could have caused the lacerations, but it's also possible some were caused by exposed edges of damaged interior fixtures. Both of the passengers at the leading end of Coach D reported finding themselves outside the coach when the vehicle finally came to rest, but could not recall how they got there. Good grief! It just does not bear thinking about. Crikey. So it's grim, isn't it? It really is grim. Yeah. The minor injuries to 3 people comprise bruising, sprained ankle. Yeah. So despite the severity of the fires on the site, none of the occupants suffered injuries as a result of fire. At the time of the accident, no one was in Coach B, and the fire broke out a considerable time after the accident. We'll get to the fire. It's a relevant thing. So that's the injuries, and in terms of learning what we can from there, we'll see as we go into crashworthiness. I think we pick up on some of those injuries. So here we go. Crashworthiness. Crashworthiness performance of the vehicles. The HST, the high-speed train, was first introduced into mainline service in the mid-1970s. The British Rail Mark III coach was designed as a monocoque structure and manufactured from welded mild steel. The structure was designed to a set of static load cases to enable it to withstand the rigours of normal service operation and resist abnormal loading in accident scenarios. These requirements were similar to current standards for static strength, but did not include the additional crashworthiness standards to which modern vehicles are designed to improve survivability in accidents, such as energy-absorbing vehicle ends, or crumple zones, and anti-override features. During a long service life on mainline railways, HSTs have been involved in some major accidents, the most recent being the derailment at Ufton Nervet in 2004 and collisions at Ladbroke Grove in 1999 and Southall in 1997. Historically, they have generally performed well in terms of maintaining structural integrity and protecting occupants. The behaviour of the train at Carmont was affected by characteristics of its design. Some of these positively affected the course of events and minimised the risk to occupants, while others adversely affected the outcome. These are discussed in the following paragraphs. So we're going to start with the driver's cab. The cab of the leading power car impacted the embankment below the bridge. The resultant speed of impact is estimated to have been around 45 miles an hour. So that's not a tremendously high speed of impact there. Yeah. The structure of the driver's cab was manufactured from glass-reinforced polymer and bolted directly to a bulkhead at the forward end of the engine compartment and the underframe of the power car. Just to remind everyone, in fact, we're going to flick back just to remind everyone what that looked like. Here is what. So if you can imagine just the shape of the front of an HST placed onto essentially a flatbed and bolted to a bulkhead. There are no structural properties in the cab. Yeah, you can see there what remains of the cab. It's just an upturned bathtub. Yeah, that's it. This is unlike most other modern train cabs, which have a steel or aluminium cab superstructure covered by a relatively thin non-structural GRP fairing that provides an aerodynamic and aesthetic shape. The GRP cab structure detached from its underframe mountings and the rear bulkhead, then broke up into several pieces on impact with the embankment. The cab roof, windscreen and left-hand side remained together and were found a distance of around 22 metres from the power car towards the bottom of the slope, close to where the leading end of coach B came to rest. The driver was found nearby. Absolutely horrific. The cab floor, left and right-hand doors, driver's desk and seat detached to the left of the power car and came to rest at various positions, either close to the power car or further down the slope. The cab was subjected to severe impact conditions. The speed of impact was significantly beyond the collision speeds for which even modern cabs are designed to provide protection for occupants. For example, the cab ends of more modern trains were designed to absorb energy and protect the driver in collisions with an identical train at a closing speed of up to 60 km an hour, 37 miles an hour. Later train designs, since around 2010, were designed for a closing speed of up to 36 km an hour, 22 miles an hour, in line with European technical specifications for interoperability, the TSIs. These design collision speeds are equivalent to a single train colliding with an immovable object at half the design speed, The estimated speed of impact between the power car and the ground at Carmont was over twice the higher of the equivalent design speeds into an immovable object. Given the severity of the collision conditions, significant damage to this or any other cab structure was inevitable. Yeah, fair enough. But I'm hoping there is a but, because the idea of saying an upturned bathtub is basically the same as a full cab structure is problematic. And I dare say this paragraph is going to point that out. Driving cabs of HSTs and more modern designs trains designed before GMRT 2100, which is the that's 2010, but actually that's referring to standard really that came in 1994. Those are not fitted with seatbelts or any other specific secondary impact protection, such as airbags and knee bolsters for the driver. Train driving cabs designed after 2100 came into force. After 2100 came into force, are required to undergo a dynamic crash test or validated simulation to prove specified injury criteria are not exceeded. So basically, they do a crash test. They get a crash test dummy in, and they do a crash test. However, these more modern cabs are not fitted with seatbelts or airbags for secondary impact protection, which previous research has identified as feasible. A significant amount of research work has been undertaken by the rail industry into providing better protection for train drivers. The earliest known work in the UK on improved driver protection measures was carried out as part of British Rail's Crashworthiness Development Programme between 1992 and 1996, and culminated in a full-scale dynamic crash test to validate the efficacy of various devices such as airbags and knee bolsters in minimising secondary impact injuries. Those tests confirmed that secondary impact protection for drivers was technically feasible. Subsequently, after Ladbroke Grove, studies were carried out into possible options for retrospectively improving the safety of HST cabs in accidents. Ladbroke Grove acknowledged that they were hopeless. More recently, the RSSB undertook a project optimising driving cab design for driver protection in a collision. That concluded relatively low-speed collisions can result in the driver sustaining serious or fatal injuries, and that it was technically feasible to provide protection for drivers in frontal collisions with a similar train at closing speeds of up to 50 miles an hour. A viability assessment concluded that following the introduction of safety systems such as TPWS, Train Protection and Warning System, the costs of measures such as airbags, knee bolsters and seatbelts would have been grossly disproportionate to benefits, and widespread installation within the industry would require wider industry consensus. Yeah, okay, fine. There's quite a long way from seatbelts and airbags to zero crashworthiness protection whatsoever, which is what the HST has. Although the research work to date had focused on train collisions, Carmont demonstrated that train drivers are vulnerable to fatal injuries arising from secondary impact with the cab interior and high-energy derailments. Yes. So, fine. And also, I suppose that paragraph is really acknowledging that a lot of research has looked at... In the past, we've assumed that trains colliding with other trains is the most dangerous thing and the most common way that we're going to see incidents. But actually, as signalling has got better, as TPWS has come in, it's almost eliminated train-on-train collisions. Salisbury was a rare case of a low adhesion event resulting in a train collision. But with increasing infrastructure pressures from climate change and potentially reduced maintenance, the likelihood of trains derailing into terrain and a crash like Carmont is more likely. Although, likewise, Watford was a combination of both, wasn't it? It was trains colliding with each other as a result of failed earthwork. Vehicle structures. The body shells of the Mark III coaches generally performed well in the accident, resulting in only limited loss of survival space, even in coaches C and D, which had rolled over onto their roofs, and resisted injurious penetration of passenger spaces during impacts with other vehicles and bogies. However, there was a complete loss of survival space in the leading vestibule of Coach D, where the train conductor was located. This likely occurred when Coach D overrode the trailing end of the power car. So, as the power car was going this way, there's a coach behind it which continued forwards. The power car was decelerating, and Coach D actually overrode and caught up with it and kind of crushed into it, telescoped into it. The vestibule is protected by 4 body end pillars comprising 2 gangway pillars either side of the flexible gangway and 2 corner pillars next to the doors. All the pillars at the leading end were sheared off at their bases. Crikey. The Mark III coach design load... No, these paragraphs start getting fiddly. The Mark III coach design load cases included compressive forces applied to the body end structure. So this is basically saying what tests there were. Yes, the pillars provide a degree of protection. They're vulnerable when overriding occurs and collision forces exceed the strength of the pillars. There's a particular issue on the lower overridden vehicle yeah, so it's just describing the challenges you have with an overriding, a telescoping event with Mark III coaches. Mark III coaches predate the current requirements for vehicle ends to be energy absorbing, and so when the pillars shear off, the body end structure loses its ability to resist intrusion into survival spaces. Mark III coaches do not have a door separating the vestibule at the end of the vehicle from the flexible gangway, which some modern trains have. There is no requirement in standards to have such doors, and some modern trains have coach end openings extending to almost the full width of the carriages. Consequently, in the event of separation between two vehicles, occupants located in the vestibule at the ends of coaches are at significantly higher risk of ejection if there are no gangway doors. Yeah. So here we get to a thing that's, to be honest, a bit of a... Yes, it's a feature of these ageing trains, but it's a bit of a red herring, really. But it's relevant and it's something that was certainly looked at given the age of the vehicles and the extensive work that was undertaken in their refurbishment. So this is corrosion, by the way. Given the age of the vehicles, it's unsurprising that damaged areas of the Mark III coach structures were found to have corrosion. The RAIB considered whether the extent of corrosion may have significantly affected the way the coach structures deformed, and in particular the loss of survival space observed in Coach D. So they looked at corrosion at the body end pillars, along the body sides, and where the body side skin panels split. So they're looking at various areas where there's corrosion. They observed corrosion at the base of the collision and corner pillars on the leading end of Coach D. In some areas, 5mm thick plates have been reduced to between 3 and 3.5mm from corrosion. It's quite a substantial reduction in section, crikey. There is also corrosion in the leading part of the underframe which supports these pillars. Corrosion repairs were undertaken on Coach D by Wabtec from June to August 2019 as part of the power door modifications. During the conversions that occurred before May 2020, which included the Carmont HST set, no formal corrosion allowances were specified for the body end pillars. So engineering judgments were made. Fine. Wabtec reports that subsequently in May 2020, guidance was introduced to assist staff deciding when repairs due to corrosion were needed. So there's no specific guide. No specific guide, but there was until guidance was introduced in May 2020. So quite a lot of repairs were undertaken before that. Records for corrosion repairs provided by Wabtec indicate that some localised corrosion had been identified on the two gangway pillars at the leading end of Coach D, and repairs were authorised. Annoyingly, though, frustratingly, there were no photographic records of the work actually done, and the pillars were too severely damaged in the accident for a meaningful retrospective assessment of this work. So that's a frustrating thing. Keep records of that sort of repair, essentially. Loss of material due to corrosion of the pillars would have weakened the body end structure to some extent. The forces applied to the pillars in the interaction with the leading power car are not known, and therefore the investigation was not able to assess whether or not the original strength of the pillars would have been sufficient to resist the applied forces. So that's, without corrosion, would the same thing have happened? They weren't able to conclude that. Yeah, it's interesting. A few people saying that corrosion is becoming an increasing issue on a lot of older stock. Yeah, that's and one of the recommendations, which we'll get to in this, certainly covers that point. So Wabtec looked at, they'd already undertaken finite element analysis to assess how their power door modifications impacted on the structural capacity at the end of the doors, and they'd established that their additional structure that they added actually improved the overall performance of the body end under the kind of the design load cases. They also indicate there was some scope for uniform material loss due to corrosion before the body end structure would have started to yield locally. Okay, so there's some stuff about the way that there's some analysed behaviour. So the RAIB reckon that although there were pockets of corrosion with more than 20% material loss on Coach D, provided the material loss in the area around the joints that fractured was localised, there should have been sufficient material left to be able to carry the kind of the ultimate loads that were specified in the standards. GMRT 2100, that is. It's also possible that even if there had not been any corrosion, the force involved would have been sufficiently high to shear the piers. I think that's quite a reasonable assessment. There was clearly a lot of corrosion, but actually it's difficult to come to the conclusion that would have been problematic, because corrosion doesn't necessarily happen where the most load is. It's not fatigue corrosion. This is corrosion just from getting eaten by moisture and so on. So the load pads might never have actually got anywhere near the areas of corrosion, and so it's difficult to come to an assessment of exactly what the impact of it would be. It's sort of fair enough. A significant crease was observed along the left-hand side of Coach D below the window line. There was also a corresponding crease on the right-hand side above the windows. This creasing led to a loss of cross-sectional shape in the leading half of the body shell, and significant loss of survival space in that area. but did not result in splitting the body shell along the crease line. Examinations of the exposed structure revealed no evidence of significant degradation of the structural members by corrosion. The creasing appeared to have been caused by mechanical overload, most likely when Coach D rolled onto its roof and Coach A landed on it. Having already lost its leading body end structure, it's likely that Coach D could no longer maintain its cross-sectional shape when the weight of the leading half of Coach A came to rest on its leading end. Vertical splitting was observed on all the coaches, but particularly on coaches C and D. I think we looked at those in the previous, in figure 82 earlier, I think, in fact. Yeah, you can sort of see... Yeah, you can see some of the... Oh, wait a minute. No. Oh, there's one coming up, actually. Okay, fine. Yeah, we've got figure 82 is coming up. Oh, yeah, okay. Because the Mark III design, because the Mark III coach is designed as a monocoque structure, the observed splitting of the skin panels is also likely to have aggravated the deformation of Coach D. So here you go. So here's figures 81 and 82 showing the way that creasing was happening. You know, a crease, a pinch, essentially like paper. You know, a crease was forming, and as soon as you get that hinge forming, then the structure, the rollover strength of that vehicle is going to be severely impacted. It's interesting, isn't it? They say they talk. The report is pretty gently euphemistic about the behaviour of the HST of the Mark III coaches, whereas given these pictures, really does look far more catastrophic than they describe. Survival space is gone where that crushing has occurred. So couplers, another absolutely critical feature. HSTs are fitted with alliance couplers, which were not able to withstand the forces and relative vehicle movements during the derailment. All the vehicles became uncoupled except at the interface of Coach A and the trailing power car. So that's the very last kind of coupler. That's the only one that remained intact. The uncoupling allowed the vehicles to scatter, to roll over, and increase the risk of secondary impact with infrastructure in other vehicles and their bogies. The typical failure mode of the coupler is fracture of either the upper or lower half of the knuckles of the coupler. These are knuckle couplers that look a bit like kind of this. So it's and they're kind of split into sections, so they kind of have like a top and a bottom bit, and the top section or bottom sections where the upper or lower halves of the knuckles were failing. The same failure mode of the alliance coupler was also noted after Nervit. So this is an acknowledged issue here. So Tom's asked a question, actually. Tom has asked, can the required crumple zones, etc., be retrofitted to old stock? No, they can't. Not at a cost less than replacing the stock, to be honest. It was already incredibly costly to fit every single door fitting to the Mark III stock was essentially bespoke because it had to fit with the fact that these things had deformed and were not manufactured particularly consistently. So retrofitting old stock like Mark IIIs is just incredibly expensive. So I'd argue that's likely to be, and we'll get to some cost comparisons later, but I'd argue that'd be likely to be more as expensive as just procuring new trains. So couplers. Oh yeah, you've got some nice pictures showing that the knuckle couplers there, those alliance couplers, and the way that they've just failed. They've just disintegrated. They've fallen to bits. They are not good couplers. So, bogey retention, another critical element of a problem with the Mark IIIs. So, bogey retention. The leading bogey, the leading power car, was found under this vehicle on the embankment with the heavy-duty wire rope retention straps broken. This indicated that the bogey had been retained until the leading power car impacted the embankment below the bridge. None of the other power car bogies became detached. So, power car bogies, actually reasonably robust and reasonably well connected to the vehicle, although, there are other reasons. Obviously, the rear power car didn't come through many forces at all, really, compared to the front one. However, Mark III coaches, unlike 2100, post 2100 vehicles, are not fitted with any form of bogey retention in the vertical direction. So that's if you've got the bogey, if you've got the vehicle here and the bogey underneath it, that means there's no with the wheels here. The bogey is the thing that holds the wheels onto the vehicle. That there's no vertical protection. So as soon as the vehicle body lifts off, those bogies are gone, right? And this allowed the vehicle bodies to lift off their bogies during the derailment. The fact that they could do that, conversely, the vehicle lifts, but likewise, if the bogies and the vehicles... So yes, if the vehicle lifts, the bogies drop off, but likewise, if some force on the vehicle can lift off while the bogies are still on the track, which is also not good. This allowed the vehicle bodies to lift off their bogies during the derailment. With the exception of the trailing bogey of Coach A, all the other coach bogies detached. In nearly all cases, there was minimal damage to the body-mounted centre pivots, indicating that separation had occurred by the vehicle bodies lifting off the bogies, most likely as a result of severe pitching movements. So that's pitch is where the vehicle is going up and down like that. So if it's bounced up, if you can imagine now, so that's me coach in sort of side view. But if you can imagine now we're following the train, the coach going forwards, that's it pitching upwards and down, likely as it's hit something and been launched upwards. So that's pitching movements. Let's see. The loss of so many bogies would have adversely affected the ability of the train to dissipate kinetic energy in a benign way by braking, and by bogies running derailed through ballast. So any chance, all of the ways that you decelerate that train are by keeping it connected to the bogies, either by braking force on the wheels, which are automatically, the brakes were emergency brakes had been applied by the driver and were actually, were they? I think they were, but it didn't reduce the speed very much. I double check that. In any case, even if they had been or hadn't been, brakes would automatically be applied as the first severing of brake pipes. So brakes would be getting applied. But more importantly, the larger deceleration force comes from the bogies digging into the ballast, going through sleepers, shattering sleepers, digging into ballast. Huge deceleration force, but still a managed one that's actually safe. Decelerating. There was a Voyager that was derailed at Cottonthorpe, having hit a car, I think, didn't it? And that train, no one knows about that derailment because it didn't result in any severe consequences. The derailed train dug into the ballast on the bogie that had derailed, and it decelerated safely to a stop. So this is consistently shown that when you keep a train upright, connected with couplers, and with bogies attached, you can decelerate. A fairly severe derailment can be decelerated fairly safely with that safe decelerating force. So, as a consequence of losing their bogies, coaches B, C, and D were also free to slide and roll in an uncontrolled manner. Attached bogies tend to resist sliding because they dig into the ballast. The detached bogies also became obstacles in the path of the vehicle bodies, and coach C is likely to have suffered some of its penetration damage as a result of striking detached bogies. Detachment of Mark III bogies was also noted in previous accidents at Ladbroke Grove and Ufton Nervett. A study undertaken by RSSB to improve the understanding of accident survivability in relation to the structural crashworthiness and dynamic stability of rail vehicles in the event of an end-on collision concluded that was a mouthful. That's a bad sentence, folks. Under off-track conditions, there are more benefits to be gained in retaining bogies than allowing them to detach. So some people say detached bogies, that's good, because you reduce the overall kinetic energy of the vehicle. That benefit is massively outweighed by the benefit of deceleration forces of retaining a bogie and also of keeping a train in line. So we're going to jump forwards to vehicle interiors. Bearing in mind this is a fairly recent refurbishment, you'd expect the interiors to perform reasonably well, right? So, vehicle interiors. The vehicle interiors perform well in the derailment despite the severe movements and rollover that the vehicles are subjected to. Great, so that's good stuff. Interior trim panels and light fittings generally remain detached except in the leading half of coach D. But even in this area, detached fittings did not encroach significantly to passenger spaces. So, all that stuff where we have learned. Refurbishment of the interiors, we understand train interiors far better. So, to the best of their ability, Wabtec and their subcontractors will have fitted. Those trains are far safer than the original Mark III internal layout. Penetration damage to the left-hand side of coach C caused the seats in that area to be pushed in without detachment, fully encroaching on the aisle space. However, because this vehicle rolled over onto its roof, the aisle blockage did not stop the 3 surviving passengers self-evacuating from the trailing end. Fine. Folding tables, specifically looking at folding tables. The folding tables used with the single priority seats at 4 locations in the first-class coach were observed to have a particularly sharp corner when in the folded position. This is an oversight in the design. This corner could cause injury to a seated forward-facing passenger in the event of a train collision in which they were thrown forwards into the table. The same folding table design is also used in coach B at 2 locations adjacent to wheelchair positions. In the coach B positions, it poses less of a risk to a passenger sitting in a wheelchair because of the side of the wheelchair frame would impact the sharp corner. When in the flat down position, no sharp edge is presented. No occupants were seated next to these folding tables or injured by them during the derailment at Carmont. So that's a kind of a point to note. Ideally, the design would have not included this sharp, this sort of sharp squared off edge. I think you can see it in the picture there with the arrow pointing to it. I can do this, I can wave it. You can sort of see where when it's folded up, there's a sort of a sharp edge presented. The design of folding table was first introduced into railway service by the Mallard refurbishment, so that's kind of been retained from the Mallard refurbishment by the sound of it. Dynamic testing of the seating table was carried out at the time to check compliance. Fine. Requirement of the standard was that all areas which could be subject to foreseeable secondary impact shall be free of sharp areas. However, there's no evidence from the available records that the sharp corner was ever identified as a potential risk, and the table design was certified for railway use. So, the table design was introduced into Mark III coaches in 2006 as part of the refurbishment project of the Mark III coaches. So the previous ones were for Mark IVs, this was for Mark IIIs. And again, wasn't identified as risk. The table design was introduced by Wabtec into the ScotRail Mark IIIs. Scope of work did not include a crashworthiness review of the folding tables, so they were continued as accepted to grandfather rights. So this is a bit of an issue here. So they're not compliant with the latest standards. There's a discussion of seatbelts. Mark III, but we won't dwell on it. Mark III coaches, fine. They don't have seatbelts. Other three, seatbelts could have been effective in reducing the severity of secondary impact injuries if they'd been fitted and worn by occupants at the time of the accident. Yeah, but there's been an open discussion about seatbelts, and I just don't. Yeah, there's a whole discussion about seatbelts. We're just going to move on from it because seatbelts are not. They're not. Those are not the issue. You know, we've seen by looking at grey rig and other incidents. Yes, the one or two fatalities can be caused by people not being held in their seat, but by and large, the interior of a train is if a derailment if a train is complying with modern crashworthiness standards, seatbelts are they're useful, but they're not they're outweighed by the benefits of other things like anti-climbers, improved couplers. So I'm not going to dwell on it. Window breakage is important though. Breakage of body side windows usually occurs in high energy accidents when vehicles roll over, are severely damaged or are struck by debris. Mark III coach windows comprise a glazing unit installed within a mounting frame. The main risk from such window breakage is that a hole could form in the side of the vehicle through which passengers may be ejected while the train is moving, usually resulting in fatal injuries. Another risk is that broken glass can cause serious cuts and lacerations to passengers inside the vehicle. Yeah, these are key issues. The windows were installed. The windows on these Mark III coaches were installed during a refurbishment in 2006-7. They're designed to comply with another kind of railway group standard. Additionally, the windows were designed to meet a set of requirements that were issued in 2006 relating to passenger containment, following the lessons learned from after Nervit. So those additional requirements were subsequently absorbed into the current standard for bodyside windows. Fine. They're double glazed windows. Fine. Laminated. There's a 5mm thick outer pane, a 6mm spacer gap, and a 7.5mm laminated inner pane. So toughened glass on the outside, laminated glass on the inside. The laminated pane is designed to provide containment of passengers in the vehicle as far as possible in the event of rollover, and passengers falling onto it. Okay, fine. In such circumstances, it's expected that you'd get the thing where the glass breaks, but the lamination means that it still holds together as a pane. 22 windows out of 61 were broken, completely broken through, as in completely gone. After Carmont, and so you can see that it's like so they're it's just a bit of an explanation of the problems. Examination of the interior of coach D showed there had been significant ingress of glass dice from the broken windows. So these windows, when they shatter into safety glass, they're the little squares of glass when they shatter, and many large shards of glass. That's more worrying because safety glass shouldn't break like that. That had become detached but they become detached from the laminated pane. So actually those shards, if it's safety glass to shatter but it's not laminated, if it's laminated then it can be shards, but theoretically the lamination should hold the shards, but that hadn't happened. Both passengers who survived the accident in Coach D suffered laceration injuries, which may have been caused by these pieces of broken glass. Okay, so here's some images of what the consequences are, and all the pieces of shattered glass. RAIB consulted Independent Glass, the manufacturer of the glazing unit, about the manner in which some of the linear laminated panes had shattered into large pieces rather than the small dice pieces, and then detached from the sort of sticky laminated layer. The manufacturer explained that the additional passenger containment requirement, which was introduced after Nervit, required the use of heat-strengthened glass for the laminated pane rather than toughened glass, which would not have provided the required containment performance. Toughened glass wouldn't have provided the containment performance. The glazing unit was also constrained in thickness to fit within existing frames. So the detachment of glass from the interlayer was caused by the distortion of the glazing unit as a whole after the laminated pane had been broken as a result of subsequent deformation of the vehicle structure. Okay. None of that's covered by standards particularly. The manufacturer stated that the observed behaviour was pretty much as expected under these circumstances, and the manufacturer advised RAIB there may be scope for improving the performance further, but that would require further research and the use of alternative materials. Okay, fine. Right, so that's all the description of... that's kind of the description of the current issues, but then the comparison with modern rolling stock. This is kind of the key comparison here. And they go through a few features and pick out how the performance and the behaviour through the derailment might have been different had a modern train been involved rather than the HST. Some people said that the RAIB were not looking at crashworthiness in any great detail, and were not and I dare say the detail here, particularly this section where there's a comparison with modern rolling stock, somewhat punctures that false statement, but whatever. Comparison with modern rolling stock. The investigation considered what might have happened if the accident had involved a train compliant with modern structural and crashworthiness standards, to assess if the overall outcome is likely to have been better or worse in terms of casualties. Okay. While it's never possible to be certain about what would have happened in the hypothetical situation with different rolling stock in the same accident, the following paragraphs discuss the additional passive safety features modern trains are built with, and whether these could have helped at Carmont. So they are still being quite mousy with the with their wording, but I think you have to bear in mind, the RAIB and the previous wording, they are very softly. They do not like being assertive about things. It doesn't happen very often. They're not assertive about things. So some of the wording we're about to read, I've read this section quite a lot. Some of the wording we're about to read is the equivalent of the RAIB accident reporter standing on a roof and shouting it across London. So bear that in mind. So lifeguards. There's going to be a picture of some lifeguards in a second. Located in front of the leading wheels are intended to be the first line of defence. And so, there have been previous accidents involving trains running into landslips. Here's Watford, an accident I've talked about quite a lot, have demonstrated that although the trains involve derail, modern lifeguards are generally capable of withstanding impacts with landslip debris on the track without complete loss of structural integrity. We've already explored the fact that a modern lifeguard has over twice the ultimate strength of an HST lifeguard. Fine. The evidence from the lifeguards at Carmont is that they lost their structural integrity while running through the debris and were unable to perform a clearing function. Although a stronger modern lifeguard might have been better able to move sufficient washout debris out of the path of the leading wheel set to prevent the derailment, there's insufficient evidence. The RAIB have insufficient evidence to determine the likelihood of this improved outcome, which I think is fair enough. I think it's difficult to say that a lifeguard would have made all that much difference. There's also, modern trains designed to Railway Group Standard 2100 with kind of low leading axle loads are also fitted with obstacle deflectors at each end of the train. HST slightly exceeds that axle load, but only by a little bit. They're quite lightweight, the HSTs, relatively speaking. More recent trains compliant with the TSIs have obstacle deflectors regardless of axle load. The purpose of these devices is to minimise the risk of derailment in the event the train strikes a large obstacle, for example, an animal or a car. Cotmanthorpe comes to mind on the track. They are mounted off the vehicle body ahead of the bogey mounted lifeguards and span the full width of the track. It's unlikely that an obstacle deflector would have been effective at Carmont because the depth of the washout material was too low to have engaged the bottom end of the deflector. Yeah, absolutely fair enough. It would have made no difference in this particular instance. Right. So this is where things start getting more prescient, shall we say. Certainly more uncomfortable to read. Modern trains are fitted with anti-climb features, either serrated pads fitted to the vehicle ends or built into the couplers, and energy-absorbing vehicle ends to prevent override and uncontrolled structural collapse in collisions. Had the train been fitted with these features, overriding between the leading power car and Coach D is less likely to have occurred, and in such a case, survival space in the leading vestibule of Coach D might have been better preserved. So I don't know if you've ever seen anti-climbers. They're like little sort of, they look like teeth. They look a bit like that, and you'll see them at the ends. On a lot of stock, they're just pads on the sort of the body end, and they never contact each other, other than if you have a situation where the vehicles are compressed together, and they look like teeth, and they're very strong, and they essentially just stop the vehicle from being able to override. And you'll see them on all sorts of stock. I think I've taken photos of anti-climbers. If you just Google anti-climber, it shows up. So so that they would have made a difference. Generally, modern vehicles feature robust couplers. So now we're going to talk about couplers, which are better able to resist the large movements and bending forces which couplers are subjected to in derailments without failure or uncoupling. Although there are limits to the ability of couplers to keep vehicles together, evidence on coupler performance from the accident at Greyrig in 2007. Now, who was it who was saying that Greyrig isn't an irrelevant comparison, and yet here we are with the RAIB using it precisely? Indicates that stronger couplers are likely to have led to less vehicle scatter at Carmont. Absolutely. RAIB has considered whether, in the circumstances at Carmont, stronger couplers might have resulted in Coach D and possibly other coaches being pulled off the bridge by the leading power car. So the kind of the counterfactual, if you like, of if the couplers had been intact, might they have made things worse by pulling everything off the bridge? While this possibility cannot be discounted, it is considered unlikely. That's RAIB speak for no chance. This is because stronger couplers working together with anti-climb devices and energy-absorbing vehicle ends should have prevented the overriding that occurred at the interface between the power car and Coach D. So that first power car coming off the bridge, and then the coach behind it. In the absence of overriding at this interface, the rear of the leading power car would have been likely to have remained coupled to Coach D. This would have increased the likelihood of Coach D continuing to run on its leading bogie, and thereby providing greater stability to the rear end of the leading power car. This might have even been sufficient to keep the leading power car on the track for longer, increasing the likelihood of it completely traversing the bridge, still coupled to Coach D. So, there's a potential that it could have stopped that impact that killed the driver, the severe impact of the power car. If it could have dragged it might well have demolished the parapet, but it could have kept the vehicle, actually kind of kept it sliding over the bridge, but at track level still. However, further jackknifing between the leading power car and Coach D beyond the north end of the bridge might still have occurred. Yeah, it's likely that having been kept in that way, it might have then dug in beyond the bridge and sort of still jackknifed. So that's what couplers and anti-climbers could have done to change the way that the vehicles behaved. Bogey retention now. Bogey retention is designed into modern vehicles by means of design load cases for body-to-bogey connections, which have been mandated since around 1988, so that bogies remain attached to the vehicle bodies as far as practicable in derailments and collisions. Fine, we've kind of discussed this already. Retaining bogies increases the chances of keeping vehicles upright and in line and minimises the risk of jackknifing and vehicle scatter. And again, so we've said that. We've also said, additionally, as bogies run derailed, they dissipate the train's kinetic energy in a benign way by ploughing through ballast. Therefore, bogey retention is likely to have led to a better outcome. That's like saying if the bogies had been kept on the train, this would have been a much less severe derailment. For these reasons, so kind of all the reasons that have just been discussed, this is the key sentence, to the point where I'm going to put it back in the slides again later when we get back to our slides after finishing the report. For these reasons, RAIB considers it more likely than not that the outcome would have been better if the train had been compliant with modern crashworthiness standards. There it is, that sentence. Critical. Although any such comparison is necessarily subjective, a comparison with the derailment at Greyrig in February 2007 provides some evidence to support this. The 9-car Pendolino train that derailed at Greyrig, which was designed to modern crashworthiness standards, was carrying 109 people and travelling at 95 miles an hour. The ratio of kinetic energy to train weight involved in that derailment was around 1.7 times that at Carmont, and it occurred close to a steep embankment, which also adversely affected the train's post-derailment behaviour, causing some limited jackknifing and vehicle separation. 1 passenger was fatally injured, 30 people received serious injuries, and 58 passengers received minor injuries. So essentially, that's making the Greyrig comparison that I made in my when I did the interim, looked at the interim report. Yeah, so I'm not going to say more on that at this point. We're going to talk about it maybe a little bit later when I bring up pictures from Greyrig again and remind us all why that comparison is relevant and is really key to understanding the behaviour of train vehicles at speed in a derailment like this. Guidance of derailed vehicles. So yeah, there's a kind of this section is about guardrails, and I'm going to summarise this really quickly because basically they look at guardrails. Remember I talked about guardrails in the interim report and the fact that standards are rubbish on them. This report acknowledges the fact that the standards are pretty ambiguous, but it does say that essentially, I think it says it here, yeah, it's showing that guardrails have been fitted after the accident. Guardrails have been fitted. So you can see the guardrails here in the forefoot, and you can see the gathering rails on the approach, these sort of wing-shaped sort of rails kind of to guide trains in. But essentially, to entirely compliant with standard, indeed going beyond standards, the distance, so this is an extract from the standard, by the way. This is my 2102. I use this a lot. This is my most used standard, 2102, probably more than Handbook 49, in fact. And it just shows the standard is pretty ambiguous. It doesn't say specifically anything about where guardrails are needed. But by the time we get to the end, there's a discussion here where it says that basically you'd have needed 35 meters, you'd have needed an extra 35 meters of guardrail, which no standard would have ever said. So guardrails, contrary to what I said in the interim report episode, actually guardrails wouldn't have made a difference in this incident. They might have maybe helped keeping things in line a little bit through the bridge, but the reality is and the RAIB concludes that it would have made limited impact on the consequences of the results of the derailment. But we do need to improve the standards relating to guardrail positioning, absolutely. So now we're going to look at fires. So there are several fires that took place. We're not going to dwell on this in great detail, but because fires were after the incident and didn't impact on the safety of anyone on board. But the power car came to rest and burst into flames. So there's a bit of information about that. So there's discussion of the fact the fires caused severe damage to the engine compartment, penetrated the clean air compartment power car behind the cab, but did not penetrate bulkhead separating clean air compartment from the cab. So it stayed confined to the leading power car and a bit of foliage around, but nothing beyond. There's a fire in coach B. Now this is more interesting because why did this fire occur? Now, the reason this fire occurred is because of these newly fitted auxiliary batteries located in a battery compartment. It contained 48 individual lead acid cells, each of which contains 2 kilos of a polymer material. They're packaged in groups of 4. Each group is contained within a polymer box containing sheets of polymer honeycomb. The word polymer has appeared a lot there, you might notice. So, in order to understand any possible contribution that the batteries may have made to the development and ultimate size of the fire, lab tests were conducted to establish how the materials used in the batteries and associated containers reacted to fire. The test showed that the polymer battery boxes and cell casing materials are easily ignited, sustain burning at ambient temperature, generally burn until little of the material remains, and burn with a comparatively high heat release rate. Oh my, none of that is good. How on earth has a battery cell got elements, plastics in it that burn with that behaviour? Really not good stuff. And so that fire was very much, you see the position of the battery box, the direction of the fire spread. The subsequent spread of the fire was as a result of the coach coming to rest on its right-hand side on the slope with its trailing end uppermost. This orientation meant that the fire naturally extended across the underframe and grew towards the trailing end of the coach. Okay, yeah, fine. So it gives an idea of that's something that needs to be revisited. How on earth have we got to the point where we're buying batteries that are that dangerous? That's a serious So there's a bit of discussion then. The report goes into looking at evacuation, and I don't think there's much to dwell on other than looking at the way the fire impacted on evacuation. The train was empty. The fire started a bit after the evacuation anyway. So you can see the fire here and the impact that it had, but the impact it's had on the interior, pretty substantial. But this happened afterwards, not good. But again, the fact the train was emptier certainly helps in this situation. Emergency egress. So this is discussing egress. Again, I'm not going to dwell on this because actually the trains were so deformed. It's not really a particular point of a particular point to dwell on. So there's some other observations that the RAIB made, and again, we're not going to dwell on these, but we've got, because it's already blinking 8:05. Good grief. Simon's pointing out that we have ROGs and fire safety regulations for materials on passenger trains, and this somehow slipped through. Absolutely. Yeah, how many other similar items of equipment are there currently on the network? Really, really bad. Just really not great. So there's some observations about route proving. Railway industry process for the operation of route proving trains were poorly defined and inconsistent, because that's what this train essentially ended up behaving as. It behaved as a route proving train. So the speed that route proving is enabled of. Fine. Emergency communication. The staff weren't trained that they could use the GSMR radio system to broadcast emergency information to other railway staff much more quickly. That was a mistake. That was a training issue. Earthworks inspections generally, network rail standards relating to the examination of mixed cuttings was open to differing interpretations and left a gap in the management of risk from soil components of mixed slopes. So that's an observation that was made. And an observation on the role of the ORR, which is interesting. The ORR regulates the railway industry's health and safety performance. Fine. It plans its routine work on the basis of risk and its analysis of where it can secure the most significant improvements in safety management. Fine. So there's a bit of stuff about earthwork management. Okay, so there's some stuff about the way the ORR interacts with earthwork management. Fine. We're going to hammer through it. Construction activities, fine. Recommendation handling. We'll come to this in the actual final report recommendations. So there's some other, so it's worth saying, it's worth pointing out that there was a failure on a bridge. It's like 2 structures further north, right? Shortly after the failure of this bridge. So this was bridge 325, 328. So 3 structures further up. Sorry, had a parapet failure. On the same line, just about a mile north of the accident site, and the RAIB just wanted to point out, they just explicitly point out there's not actually an overlap in the sort of relationship between these 2 incidents, none at all. So we've got our summary of conclusions of causal factors. We'll come back to we've got our own of these, so I'm not going to rerun this again. The underlying factors and the examination of the consequences. Particularly the unusually low number of people on the train because of COVID. It's a particular help to reducing the number of fatalities. Some other observations. So there are some actions that have been reported as already in progress or relevant to this report. There's some stuff generally. Scott really said that it intends to change training for conductors working on HSTs, so it include entering the driving cab and locating the GSMR equipment. So that's good. So that's happened. New drainage system was installed at Carmont. That's good. Guardrails are fitted. Network Rail stated that its project teams had started to review historical projects up to 10 years old to ascertain whether a health and safety file had been accepted by NRG, National Records Group, and stored appropriately. So Network Rail in Scotland are doing that. Whether that's happening elsewhere, I'm not so sure, but in Scotland that's happening. NR Standard 02009 was updated and reissued. So actually, this is interesting. So they updated INI to RSE, intended to strengthen the management of technical queries raised during construction and the process for controlling changes to the design. So they've made that more robust. That 02009 is like the standard that runs how I do design, how I interact as a CRE, what my responsibilities. They define what my responsibilities are as a responsible engineer. As a design lead, and they define everyone's responsibilities. This is like the key, one of the most important standards that we use in the industry, from a design and from a construction project's perspective. So they introduced expanded drain design requirements. So that they updated that was in 2018, fine, and that sort of helped, they believe, but it doesn't explicitly state whether consequences beyond flooding should be considered. Okay. Yeah, so there's a load of things that are being done. There's changes. Network Rail have reviewed a few. There've been a few audits. Generally some stuff there. There's some the 2 task forces that came off the back of this report. So the Weather Advisory Task Force and the Earthworks review, the Earthworks Task Force, 2 reports that were published off the back of that, fairly substantial reports. We're not going to go through those as page turns anytime, but they're worth flicking through in your own time. So they're worth looking at. It'd be good to, if we could get Dame Julia Slingo in to that'd be interesting. I want to get some Met Office, some people. Yeah, it'd be quite interesting if we could get either of these, the chairs of these task forces in onto NATA. That'd be good. But are we that important? Who knows? Feel free to email them and ask. Neither task force was asked to investigate the accident in any detail, but their findings are informing Network Rail's ongoing asset management processes. Yeah, fine, okay. So we get to the recommendations, and there are quite a number of recommendations in this report. The first recommendation, number 1, is it recognises the evolution of processes since that drainage scheme was constructed, and it's to ensure that the current process, basically it's to say Network Rail should review its contractual and project management arrangements to identify effective measures to reduce the risk of contractors modifying a design and ensure timely provision of accurate records. Key things. Number 1 recommendation. The number 2 recommendation is that Network Rail should take steps necessary to ensure that all elements of infrastructure constructed in Scotland since 2012 are included in the appropriate asset management processes. Extend the time frame to include work constructed before 2012 on a risk management basis. Determine the extent to which similar steps are required on network rail infrastructure outside of Scotland, and conduct an audit review covering the implementation of existing arrangements to identify, report, and correct asset database management and data quality issues. So this is kind of asset management database recommendation. That's recommendation 2. Recommendation 3. Network Rail should review and update its drainage-related procedures so that the output from the design process takes full account of likely impacts on railway safety due to flooding and or debris washed from drains and or surrounding ground. Fair enough. Recommendation 4. AMI and Network Rail should jointly review the way that they are implementing the requirements of CIV 65, Network Rail standard, that relate to mixed cuttings and the reporting of incomplete examinations. So this is to do with this confusion about where the inspection sort of remit stopped and how much they needed to inspect. Recommendation 5 is in parallel with the implementation recommendation 4, Network Rail's technical authority should evaluate the adequacy and ways of improving the clarity of CIV 65 requirements that relate to the examination of mixed cuttings. So again, this is related to inspections. Recommendation 6 is Network Rail should review and improve its processes for mitigating rainfall-related threats to the integrity of its earthworks and drainage infrastructure. Recommendation 7, this is a chunky old paragraph. Network Rail, in conjunction with the train operating companies, should review the capability of route control rooms to effectively manage complex, widespread and unusual situations, such as abnormal weather conditions and multiple infrastructure failures. So that's the management, the team management, the crisis management recommendations now. Likewise, the management assurance system, Network Rail should undertake a project to improve the way its management assurance system operates in relation to safety critical functions. So this is about staff competence. Recommendation 9, Network Rail, in consultation with the ORR, should review the effectiveness of recent changes to its processes for ensuring that appropriate action is taken in response to safety recommendations. Okay, fine. So that's a Network Rail ORR combined. Make sure that you're doing what recommendations from the RAIB say you should be doing to avoid missing things that have been suggested. Recommendation 10. So again, this is about mitigating controls for failure. So Network Rail should undertake a detailed and systematic risk assessment of the mitigating controls that relate to weather-related failures of earthworks, drainage and structures. Fine. Recommendation 11 is where Network Rail, assisted by the RSSB and RDG, should determine the objectives of the operation of route-proving trains. So this is basically, this is about route-proving trains. So it's identify hazards which staff operating such trains are expected to identify, circumstances in which route-proving trains should be operated, and how they should be operated, including things like train speed and the effect of reduced visibility. So, it's a bit of that HST was acting as a route-proving train, and it should really have been running under caution. It's not the fault of the driver or the signaller, but the processes were not sufficient to ensure that it was known that it was a route-proving train and should therefore have been running at caution. So, long-term strategies. Well, this is going to get ignored, isn't it then? Recommendation 12 is about the Rail Delivery Group, Network Rail, in conjunction with RSSB, considering and incorporating the learning from Carmont into the assessment of rolling stock and infrastructure design features that can provide guidance to trains when derailed. So basically this is about improving where we propose things like guardrails, robust curbs, these sorts of things, reinforced parapets. Recommendation 13 is about, again, it's about guardrails specifically. So the previous one was a bit more broad. This is a bit more specific about guardrails, fine. Recommendation 14 is stating that owners of HST power cars should investigate the feasibility of enhancing the strength of the bogey-mounted lifeguards as close as is reasonably practicable to modern standards. So they're saying, please, for goodness sake, enhance the lifeguards if you can, because they could make a difference. Recommendation 15 is talking about bodyside windows. We talked about lacerations and cuts, so that's the recommendation of that. Recommendation 16, this is about Angel Trains looking at those folding tables to try and get rid of that sharp corner, and ideally replace them, provide a time within which those are going to be replaced. Recommendation 17. So this is, so this is basically the RSSB should review its previous research on fitting secondary impact protection devices for train drivers. Okay, so that's a bit of a... RSSB should do that. Nothing's going to come of it, frankly. Recommendation 18 is that owners of Mark III coaches and other rail vehicle fleets susceptible to significant levels of corrosion, this comes back to stuff that you were saying in the chat, folks, that they should develop and implement a time-bound plan to review vehicle maintenance and overhaul plans, and confirm that there are, basically look at corrosion and ensure that it's not a threat, that it's not a problem, and amend vehicle maintenance and overhaul procedures as necessary to take account of these findings. Yeah, fair enough. So, recommendation 19. This is the key one that the unions rightly jumped on. Operators of HSTs in consultation with train owners, ORR, the DFT, devolved nations, transport agencies, and the RSSB should do the following. 3 things stated here. First, assess the additional risk to train occupants associated with the lack of certain modern crashworthiness features compared to trains compliant with modern standards, including taking account of things like corrosion. This assessment should include a review of previous crashworthiness research, a review of previous accidents, consideration of future train accident risk, the findings presented in this report, and any relevant engineering assessments. So, thorough. It should happen. So this should happen, and it hopefully should be published. Based on the outcome of and cost-benefit analysis, raised eyebrow, identify reasonably practicable measures to control any identified areas of additional risk for HSTs and develop a risk-based methodology for determining whether, and if so when, HSTs should be modified, redeployed, or withdrawn from service. There you go. And in consultation with operators of other pre-94 rolling stock, develop and issue formalised industry guidance for assessing and mitigating the risk associated with the continued operation of HSTs and other types of mainline passenger rolling stock designed before those modern crashworthiness standards. So recommendation 19 is the one that is sort of saying in a roundabout way, think a bit more hard about whether HSTs should still be in frontline operation. Recommendation 20... Graham, I absolutely share your sentiments on this. Just electrify and get new trains out there to just avoid this rinse and repeat cascade nonsense. Absolutely. And I'm going to dwell on this point a little bit in the slides because I think it's relevant to look in detail at that and at some of the other factors at play in the particular choices ScotRail made on that front. Recommendation 20 is about those batteries. It's about it's basically the it's the RAIB going, what the hell is with those batteries? What the hell, guys? So that's good. And there's a learning point here. So there's a little learning point for everyone. Just one learning point, which is railway staff are reminded that if available and they're trained to use it, GSMR radio is normally the most appropriate way to communicate urgent safety information to signallers. So there you go. It's just a key one, because it would just go straight to the nearest signal box. HSTs are already in museums. That doesn't say a lot for whether they should still be in frontline operation, does it? Anyway. So... that's the report. The appendices are, there's a glossary, there's some stuff, there's this particular disruption schedule, there's the accident sequence that we've seen. We've looked at we've got the videos that we'll look at again. We've got actually, it's interesting, they've broken normally this is within the body of the report, but you can see that this goes into some detail and kind of specifically talks about what is happening where and at what point. You can see couplers failed and all sorts of failures, and it's a mess, isn't it? Falling off the bridge, the jackknifing, what a mess. Anyway, we'll remind ourselves of that. Condition and damage to the bridge. So this is looking at the actual bridge, the track and bridge. So it's just detailing. It's interesting. This stuff is normally within the body of the report where they've pulled it out, which is kind of fair enough because it is slightly tangential. So you can see that there's some sleeper damage and some impact to the track, and you can see the mess here, and the fire still blazing. Photo taken pretty soon after the crash. Actually, it's pretty horrifying. Here's a drawing of where the tracks were in relation to the parapets originally. Not originally. Sorry, that's from 1980. That's just a hand sketch that's been done in 1980. I should have recognised the style of the handwriting. It's comic book text. This is shortly before the accident. Interestingly, this has literally been taken just before the accident, showing kind of a picture of the bridge. It's a strange story we're down there. Remember, the story are sort of some of the heroes of the piece because their staff immediately got involved trying to. They already started trying to create a makeshift. They're trying to create a makeshift track to for people to get access to the train. I think they were putting fires out themselves. They're helping people. Just heroes of the piece, really. There's the damage to the bridge, the repairs that happened afterwards. There's the repairs. You can see they're fairly hasty, not particularly sensitive repair, but fine, it doesn't matter. It's doing exactly what it needs to do. Some major scar protection works going on at the bottom of the structure here, so you can see this is elevating where the water flows. So that's happening. Historic land drainage issues. So this is stuff we've looked at already. Analysis of bottom debris and weather forecasting and previous occurrences. Bridge 328, just showing this happened. Remember this happened? The whole parapet just fell off. Really not good. Just fell off, but it was unrelated. Mostly unrelated. Yes, so fine. Drainage design, okay. Railway standards that were used. And that is the end of the report. We've done it, folks. Hopefully that was... I know it's very detailed. I know it was very detailed, but hopefully that was useful as a way to... that's a lot of hours of us going through the report in a lot of detail. It's slower than if you just sat and read it yourself. But hopefully in the discussion we've had, in the chat, we provide a bit of context. Absolutely. There are some interesting people going, where's the money coming from to fund this new stock? That's no. I mean, firstly, it's not safe. We should be replacing it. The cost should, the stock is bad stock anyway, let alone its unsafeness. But that's missing the key point about this particular crash. We'll get to that momentarily. So, what are the 3 C's? A reminder of the 3 C's. They're the things to remember of the key learning from this report. 3 C's: CDM regulations, crisis management, and crashworthiness. We're going to start by reminding ourselves very briefly about the CDM regs and what that actually means. So, a reminder that is this a video that's going to play? I remind myself. Is it working? That's the next question. It is, but weirdly it's not playing. Why is it not playing? It should be playing. Play. That's annoying. Wait a minute. I shall fix this by getting the and do this and just go there. That should fix it, right? No, why is it doing this? It's fine. I'm gonna press. No, that's very strange. Why is that not working? Oh, it's possibly because it's a very slow video, so it is actually playing. But let's stick with it. Just getting distracted. Oh yes, okay. So here's the funnel. This is the CDM regulations. So it's a reminder of this to do with the drainage. So there's that funnel and the washout, and then what was replaced, and that bund. And what the bund did is focused all that water to a very heavy flow rate, which then so you can see there's that bund that was just randomly added, flowing into the drainage system, which then washed out essentially. So the bund focused the water and ended up in this sort of flood kind of washout. So you can see what's happening here is that the extra flow from the bund has washed the material out, and then resulted in that big pile of debris kind of adding in, and you can kind of see where that washout has occurred, and the debris down here. So there it is, washout. You can see where the train ran through it. You can see all the material. And how did that happen? Well, it happened because of a fundamental. You can see the consequences of it. Sorry, there's the consequence. You can see the position of the. Where's OBS? I need OBS up. Position of the washout, and then the train derailment. You've seen this picture a few times. This is from the Evening Express, I think. This picture, and CDM regulations. So firstly, this relates to the regulations themselves. They were updated in 2015, originally introduced in 2007. The CDM regulations 2015, and those define the responsibilities of people involved in construction projects, right? And Network Rail, there are a series of standards from a track perspective, but kind of so overall, there's this business process standard, which is basically the link between the HSE legal instrument, the CDM regulations, and Network Rail's processes. This is the way that those processes are interpreted. from an engineering perspective, the actual standard that we live and breathe is 02009. It's this one that I've just put up. Engineering management for projects. This goes into the detail of the responsibilities of individuals and organisations or parts of organisations in relation to construction projects. This was not followed, which is why the problem. That's why the problem occurred. This is why it happened. And then from a track perspective, our standard that then ties into 02009 is TRK 2500. And that then goes into details about what specifically a CRE for track does, how we relate to the what's now the route engineer. So these are the 4 sort of documents that are worth having a hold of and understanding as engineers to understand this process. So the drainage standard is actually Civ 65, but again Civ 65 is the actual design standard, but the civil engineering assurance arrangements for the design and construction of civils assets. I don't know what the civils one is actually, but certainly from a track perspective, track used to be drainage, now it isn't. Drainage is now civils, so I don't exactly know what the civils standard is, but this is the track one. CDM, Construction Design Maintenance Management Regulations 2015, is the legal framework within which construction projects sit, and it's about defined roles, about who's responsible for what. That's what CDM is, David. So there's a whole episode on explaining CDM, and to be honest, just go into the Wikipedia article because it explains it it neatly explains what that structure is and the responsibility of the client, the contractor, the designer. The relationship between designer and contractor is very clearly defined. It's very clearly defined what a contractor can and cannot do, and what a designer can and cannot do, and where those lines, and how those boundaries between those organisations cannot be blurred. So that was the CDM regs. Next, we're going to look at crisis management because we know that there were lots of issues going on. So we've got the focus here of the fact that the train was used to route prove, which was fine, but the standards weren't rigorous enough about what route proving meant for the train. But also, before the crisis management, before this, there were all sorts of incidents popping up around Scotland, and they were not being managed correctly. The process by which these were being managed was not correct. So it's this is a key load of learning, and it's a bit wordy and not easily represented in an image. But there's obviously a lot of learning about the crisis management failures in the report that we've gone through. And of course, fundamentally, crisis management is only ever more critical with climate change. Climate change is meaning that we're having more of these events happening. So crisis management is absolutely critical. The behaviour under crises, under extreme weather, is absolutely is only going to become more critical as the changing climate means more extreme weather events. I was in fact teaching about this a few hours ago for the PWI. And the last point, of course, is crashworthiness. Now, there's a lot to learn. The primary cause is CDM regulations and crisis management. Absolutely key that we pick things up. And I'm not suggesting that crashworthiness is somehow more important than these, but it's a thing that the failures, the infrastructure side failures, the failures of the designers, the failures of the contractors are well explored. I think everyone can agree on that. Where there is disagreement, and which is why I'm going to go into the crashworthiness thing in a bit more detail, is in relation to the HST and the continued running of the HST, which is why I think it's relevant to look at this in detail. Not a huge amount of detail. We'll be finished quite soon, actually, but I just want to pick out some points here. So this is a quote from Stan Robertson, the Chief Inspector of Railways from 1998. Mark 1 trains are now 25 to 30 years old. In normal everyday use, they do not pose unacceptable hazards. However, they do not meet modern crashworthiness standards of construction. Quite a straightforward statement about Mark 1 trains back in 1998, that they were up to 30 years old. The same absolutely applies for Mark 3 coaches. It's absolutely key. Mark 1 trains were outlawed. They were told to be got rid of after Clapham, and they hung around for quite a lot longer after that. Really, we should have been much... I think that there is a bias within the... Yes, the Mark 3 coaches are much safer than Mark 1s, but by comparison, they do not perform well in... They have not performed well in several crashes. After Nervet, they performed dismally. They perform really poorly. You compare them to other incidents where other trains, if another train, not an HST, but a Voyager or an IET had been in the same circumstances, it's very likely it would have performed very differently in that crash, and that was not drawn. The report did not make that point vigorously enough, and I think that's it's really not to the credit of the authors of that report, that they did not reflect some of their personal views about the HST more vigorously in that report. So it's right. Let's just quickly remind ourselves of some of these facts about the kind of the three passenger coaching stock, the four passenger coaching stocks being run, or the three. So the Mark 1 coach retired from mainline service in 2005, 54 years after introduction. Mark 2 coach retired from mainline service in 2012, 49 years after introduction. Mark 3 coach still not retired from mainline service, 50 years after introduction. Its time is up, folks. This is a museum piece, and it's kind of like, you know, these are the kind of the key points that we've already looked at in here. You know, the anti-climb features, absolutely critical. The robust couplers, critical in the behaviour. That if the couplers had behaved properly, the chances are that there are reasonable chances that the severity of the incident would have been massively reduced by in the way that the vehicle would have decelerated more kind of in a more controlled manner. The power car may well have not dropped off the bridge and hit and struck the embankment as severely, which could have changed the forces on that vehicle. You know, the impact, this paragraph particularly goes into the impact, the benefits or the negative consequences of how poorly the couplers behaved. And after Nerve, it was pretty explicit about how poor the couplers performed. Likewise, bogey retention. After Nerve, it pointed out that bogey retention is a serious flaw with the behaviour of the Mark IIIs, and that this could have had a seriously beneficial impact on the behaviour of the train. These two in particular are absolutely key for that, and this is precisely why the RAIB have made this explicit statement that they consider it more than likely than not that the outcome would have been better if the train had been compliant with modern crashworthiness standards. This is why this has been said explicitly, and as I said, this is the equivalent of the loudhailer off the top of the roof. You know, this is a very loud statement for RAIB in the way that they word things. So, what is this? What are we looking at now? This is Greyrig, and you can see that Greyrig was a seriously severe incident. You know, we go back. You know, Greyrig. They're picking out Greyrig here. Why are they picking out Greyrig? Because actually, the incidents at Greyrig and Carmont are eminently comparable. Lots of factors that are similar between the two incidents, and you can see the difference in behaviour. You know, it doesn't take much to sort of compare the two and see the difference in performance of the two, you know, of these two incidents. You know, the way that the particular, you know, look at the behaviour. This coach here just completely destroyed. The rolling over onto its roof, the bogies everywhere, just buried in all over the place. Compared to Greyrig, where retained bogey, bogey retained, you know, bogey retained here, bogey it's retained. Massive difference in the performance of the vehicles. Massive performance. Also, substantial forces through the cab. The driver was seriously injured. The driver of the Greyrig 390 was seriously injured. But you can see that the body of the cab exists. It still exists. There is some crash structure protecting the driver from being tossed onto the embankment amongst a load of shattered fiberglass. You know, just the comparison of, I think I don't have a picture of there are other pictures showing where the cab ended up, and it's pretty horrific. And again, let's look at this force. Let's get it in my mug, and just very quickly look at this table that I did from the last report, from the interim report thing, right? So the speed at Greyrig was 95 miles an hour. The speed at Carmont was 73 miles an hour. It's not just about that, as David, as you rightly pointed out several times. It's not just about speed. It's about the rate of energy dissipation, and we didn't know that when the interim report came out. We do now know the rate of energy dissipation because we know how rapidly the vehicles decelerated. We know that the vehicles decelerated in 9 seconds at Greyrig. They decelerated in 15 seconds at Carmont. We know that the energy involved at the report itself is explicit about that there was 1.7 times the energy to train mass ratio. That's what they drew attention to in the report. The RAIB drew attention to in the report. We can see that, you know, there's 421 megajoules of energy of the Greyrig train, 145 of the Carmont train. You know, the train was slower and weighed less, right, at Carmont. So combine that with a slower deceleration overall, you have a substantially reduced rate of energy dissipation at Carmont. The Carmont involved only about 21% of the average rate of energy dissipation as at Grey Rig. And yes, that's an average. So that's not picking out the fact that there will have been spikes of acceleration and energy dissipation. But likewise, there will have been at Grey Rig. That the initial vehicle struck OLE masts. There were other things. The embankment was steeper. And this is not like they're nominally similar. It's only a slight difference. There is a substantial difference between these two. There's a huge difference. Carmont involving only 21% of the average rate of energy dissipation is a massive difference. So Grey Rig, more energy, higher rate of energy dissipation, and substantially better vehicle performance. And it's worth then just kind of looking in specifically at the summary paragraph about this, because they really reinforce this point. In the RAIB really reinforce this point in the report. A train built to modern crashworthiness standards would have had a number of design features that are intended to provide better protection for occupants and keep vehicles in line should they collide. So it's the anti-climb features, the more robust couplers, and the bogey retention features. These are the three key features that the HST just lacks. It was designed and constructed before the standards came into force, the HST, and RAIB considers it more likely than not that the outcome would have been better if the train had been compliant with modern crashworthiness standards. So they're rewording it, but they're being explicit about that. Let's kind of remind ourselves of the way this the progress of the report and how that would have influenced things. So I'm just going to click out of here to just say, so at this point, so the emergency brake was applied. So you see the emergency brake was applied here. Just going to do this again. So actually, I'm going to go through this again. Yeah, so at this point, I'm going to just wibble. Actually, I'm going to do this and we're going to go back and watch this again. So if I click on this, does it pause? Oh yeah, it does. Good. Right, I'll do that then. So the train comes along, it strikes and derails here, and at this point, this is where there's not really any difference. The train is derailing, but the way it's derailing, it might have swung slightly less with the couplers, but actually I think the report earlier states that less, the trouble is this cess is quite low, so the vehicle is naturally rolling to this side. But the striking the parapet end, this is where the lack of strong coupler and the lack of anti-climbers and the lack of crumple zone at the end of this coach, at this point, this is severed. These are now two separate trains, essentially, moving in different ways. If this is maintained, then this is where it's saying that the rest of the train could have kept the power car in line and stopped it from rolling off the train off the bridge like this. It would have kept it in line here. The momentum would have pushed it forwards without it dropping off the bridge, which would have avoided it having this collision with this dramatic collision with the embankment. The other thing worth noting is as the train comes along here, you can see. So we're just going to watch this through again. So the train comes off. If we're watching now, the point at which you can see these, the vehicle at the end, this is striking the embankment and jackknifing. Again, if this train had remained on its bogie, it would not have struck the embankment in quite the same way as it had. It would have been bedding into the ballast. Likewise, immediately you see the lifting of these vehicles has meant they've come off the bogies immediately. So this is an example where you can see if they'd stayed on their bogies, if the bogies had been retained, they'd have been digging in. The extra mass of these bogies would have held the vehicles, the bodies down. It's quite clear that that this is a serious contributor to the severity of the incident. Again, that means that the vehicle threw over here, dug into the trees and the embankment, and meant that there's another jackknifing incident and another sort of lateral force being applied to the vehicle. So this train is spreading all over the place because of you can't see me gesticulating wildly. It's spreading all over the place because of the coupler weakness and the lack of bogey retention. This is fundamental. And you can see the train energy is being substantially dissipated at this point. But it's not, the story's not over. The pushing of these two coaches then over the top of this coach here then means that coach got obliterated. It got crushed. It's really not a good state of affairs, and I think it's quite, it doesn't, watching that animation over and over again, you can see the severity of, where things like anti-climbers, crumple zones, stronger couplers, and bogey retention would have reduced the severity of the incident. Combine that with the fact that the train was pretty much empty, and it gives you a feel for... So yeah, combine that with the fact that the train was empty, it doesn't bear thinking about if it was outside of COVID times or if it was more recently. It's just, yeah. The HST did not cause the crash at Carmont. I'm not suggesting that. No one's suggesting that in their right mind. But it did, in all likelihood, result in it being a fatal derailment. That's the statement I'm willing to make, given the evidence that the RAIB have put forwards. Willing to stick my neck out and say that this wouldn't have been a fatal derailment had a modern train been involved. And that's how serious this is, right? Another key point, as I'm saying, to draw attention to is the fact that, the idea that, this question, would the consequences have been worse if more people were on the train? The RAIB are explicit. They say the circumstances of the accident and the resulting movements of the vehicles was such that with normal passenger numbers, the casualty toll would almost certainly have been significantly higher. Again, that's like RAIB. For the RAIB, that is as assertive as they could put that wording. They're basically saying many more people would have died if it wasn't for the fact that COVID had kept this train empty. There's another point that I want to make. We've had a few people in the chat going on about, what about other rolling? A lot of people were saying when I was talking about Crashworthiness, it's like, oh, what about all the other Mark III rolling stock? What about all the other pre-1994 rolling stock? And other people saying, oh, replacing the HST fleet will be costly. Well, those are both kind of straw man points, because that's not really what's at question here. The challenge that I'm making here is that, there's lots of other points that are made broadly around this idea. The point is that ScotRail had a choice. They made a choice. Whoever it was within the organisation, whether it was from Transport Scotland, whoever it was, based off that stupid survey that asked people in Aberdeen which train they prefer to take, and interpreted it as, rather than interpreting the train with more seats in it, they thought, oh, it must be because it's an HST, and so procured HSTs. Absolutely monumentally bad interpretation of data. But anyway, ScotRail made a choice, right? And they made a choice to spend, as in amongst all of their overall rolling stock renewal, they spent, Abellio spent £475 million on their fleet renewal, including HSTs. So that's not the total cost of the HSTs on their own. I think the HSTs was 54 million, but the overall cost, including the HSTs and the new trains, was 475 million. Right? Bear that number in mind because it's somewhat relevant. I'm just going to change whether my cursor gets captured. Sorry, just doing a bit of admin. So now I did a bit of a Twitter thread fairly recently looking at what the cost might have been had ScotRail gone with new trains, because a lot of people are saying, oh, it would have been so much more costly. If ScotRail had gone with Stadler flirts, and bearing in mind that the flirts weren't such a well-known quantity at the moment, but if they had, the cost of the fleet renewal, and I can provide the sums, there's it there on the Twitter thread, the cost of fleet renewal would have been 613 million. These are all in 2015 prices, by the way. The cost of going with IETs would have been 671 million. Now, this is not a huge extra cost. This is about 30%. It's 30%, and this is about 40%, right? So for between 30 and 40% additional capital expenditure, they could have not got HSTs. They could have gone with a train that has a longer life expectancy, because these were only the HSTs only have a shelf life of about 12 and a half years. So they could have gone for getting rid of the HSTs. They could have gone for a train that would have lasted through electrification. Could have been, the flirts and the IETs are bi-mode potential vehicles. So there was a choice made, whether it was by ScotRail or by the Scottish Government, by Transport Scotland, by MSPs, uninformed MSPs, but people lobbied for a bad choice to be made. And ultimately, the people responsible are the ones who made that choice, right? Just to remind everyone, that's in 2015 prices, not in current prices. So It's also worth just reminding ourselves about what this, so yeah, the refurbished HSTs had a 12.5-year lifespan. They have a 12.5-year lifespan, and they're incompatible with electrification. Flirts or IETs have a 30 to 40-year lifespan, which is compatible with electrification. So for 30 more lifespan, so for 30% more cost, you'd have got 30% more lifespan. Yeah. So for me, this feels like a very bad decision was made, right? A really bad decision was made. And it had severe consequences. It didn't necessarily have to, but in this case, it had severe consequences. And this is not me pointing a finger at ScotRail. This is not me saying that they're in some way culpable or negligent or any of these things. What it's saying is we need to think hard about data and think hard about the consequences of decisions we make. I was lecturing today about sustainable railways and about the fact that every decision we make has long-term consequences about railway sustainability and broader sustainability. So, I'm being kind. Yeah, Socorro's saying looks like more than 30% lifespan, looks like double the lifespan. Yeah, I'm being kind of kind to it, even if there's more lifespan. Like, yeah, it's like 12.5 versus, yeah, it's almost double the lifespan for 30% more cost. So yeah, you're right. It could actually, right. I can even type that right now. There we go, everyone. I've done it. I've fixed it for you. I've corrected my slides. 50% plus more lifespan for 30% more cost. Yeah, absolutely. So, that's a good. Yeah, that's a good. Oh, percentages. Yes, into make it 140% plus more. Yeah. Yeah, that's a good point. That's a good point, actually. 35 to 100 and trying to, it's probably 150% more. Yeah, you're right. It is. Yeah, let's correct this. I'm talking about data and stats, and here I am screwing up my percentages. I think you get my point. For a lot more lifespan, not much more cost, right? So this is my point that I believe vigorously in. Yeah, also with the flirts, which are better, frankly, than the IATs for the simple fact that they provide level boarding. The HSTs should no longer be in regular service, either passenger or freight. Sorry, intermodality, but I don't think HSTs should be running as freight trains either. I know it's because they're cheap and they're out there, but frankly, the power cars are not safe. Swap the power cars out, keep the Mark IIIs if you like, but I'd prefer them to just go and safe modern rolling stock be procured instead. So, Carmont, the 3 C's at Carmont: Cdn Regulations, crisis management, and crashworthiness are the things that we need to remember. And these are. It's really important that we take the lessons away. I think the key lessons to learn and take away are the CDM regulations, the crisis management stuff. From me as an engineer, the CDM reg stuff is by far on the top of the list of things that I personally can learn from. But crashworthiness is something that we as an industry, and frankly as a commentariat, need to be more careful about, because when the power cars are being procured, when the HSTs were procured, some people wrote pieces decrying the unions for challenging whether this was a good idea or not, and suggested that they were as good as modern trains, that no one would be able to tell the difference, and actually were quite assertive in talking down dissenting voices about the HSTs and whether it was such a good idea to introduce them versus others. And I think the people who write favourably about them need to have a little think about where HSTs sit in their own minds, because I think there's a lot of a case of people who are writing about these trains see them in a certain point as being modern because that they were modern when they were kind of for the generation of people who are writing about them, and they need to just step back a little bit from that, because they are actually as old to the world now. They are as old as Mark I coaches. They're as dangerous as Mark I coaches in operation. So we just need to have a think about that. And there are lots of people who stuck there who were shouting rather aggressively at me when I talked about crashworthiness of HSTs at the time, and I'm sorry, but the RAIB report has just vindicated what I was saying at the time, because Carmont was a mess. It was an absolute tragedy. It was a human tragedy. It was an engineering disaster. Hopefully we've learned a lot from this. There's a lot of learning, a lot of recommendations. Hopefully this series of matters has been a good way to pick through. I don't know, maybe this hasn't been everyone's cup of tea, but hopefully it's been a valuable exercise. yeah, I think it's been useful to pick through what we can, learn from what we can. These are iconic trains, right? But their time has passed. They're museum pieces. They should be consigned to a museum. And it's also worth just a quick mention for the RAIB investigators. You know, it's very, very good work. You know, it's a good report. It's an exhaustive report. I think it's a really good piece of work that should be looked after in great detail, you know, and sort of heeded by everyone across the industry. And it provides us some serious tools as engineers, certainly, to push back on things like drainage corners being cut, things like, oh, can you just quickly do that bit of documentation, don't worry about as-built, that sort of thing. Really, really good stuff from an engineering perspective, stuff that I'll take forwards and I've already used in my day job. So, this is available on all good podcasting platforms. It is for the audio only people. I don't know how well this has worked for you in audio only form, but hopefully some useful points made. It does work better as a graphic medium, I promise you. But for those of you who do just listen, hello. Patreon.com/Gareth Dennis to make more of this happen, to support this stuff to happen. The merch is out there. masket.co.uk/collection/railnatter. You can all go and sponsor. We definitely need to abolish the Treasury mug to send to Rishi Sunak. You can do it. Buy it off the website. Put bubble wrap around it, or rather, when it gets delivered to you and you know it's from Masket, wrap it in wrapping paper, stick the Treasury address on it with Rishi Sunak's name on the top, and send it over to him. Let him receive it. Hopefully he'll tweet about it. PayPal.me or Instagram it, or whatever it is that Rishi Sunak's brand team does for him. PayPal.me/Gareth Dennis to throw loose change at me. And then for more of the chat, discussion of all sorts of things, and hints about upcoming reboots to series or relaunches of previous series that I'm quite excited about, go to the Discord server, garethdennis.co.uk/Discord. Do it. Next week's episode is episode 114. We're revisiting an old format. You remember the just what structure should Britain's railways have anyway? We're going to revisit that format and have a think about it. Because I was having a discussion while I was meeting people and meeting Network Rail's head of buildings and architecture. It got me thinking about branding and about how GBR might be branded and how that branding is going to interact with current branding, particularly the devolved cities and countries and nations. So we're going to look at just what branding should Britain's railways have anyway. We're going to do it. We're going to have a look at this. Lots of questions. So that's next week's episode. We're going to go to Big Face. Hello, everyone. Questions. At me in so I can see your questions. HST Trains is asking about the Mark IVs. The Mark IV coaches are they include not all but a substantially larger number of crashworthiness features compared to the Mark IIIs. But they are, again, they're the Mark IVs. The thing with the Mark IVs is that their days are kind of numbered anyway by the fact that they gauge a bit differently to the Mark IIIs. So there are fewer of them about, and but they include features that the couplers are better than the Mark III couplers, for example. In the instance they've been shown to perform better than Mark IIIs did. So yes, so that's Mark IVs. All of the, where are we? Let's see. Any other questions? There was a question. Yeah, so that's a question about Mark IVs. That's that. I've seen all the. Oh, wait a minute. Will Tucker. Do procedures for route proving trains now preclude use of trains which don't meet current crashworthiness standards? I don't know. That's a good question. I don't think so, actually, because that would preclude like all Class 37s and all of the yellow trains and everything. So no, I don't think so. It's more about running at caution, running in a way that allows you, if it's a route proving train, then run at caution. So if you spot something bad, you can stop in advance of it, or certainly stop before the consequences become severe. I never say hit the like and share or subscribe button stuff, because it's irritating and I enjoy not saying it. But it is true. Do click a like, because the algorithm. Not many people watch Rail Natter, believe it or not. In terms of compared to people like Jeff pulls in the big numbers. I don't pull in big numbers. It's a niche thing, Rail Natter. But you're all a very dedicated group, and I love you all very much. So, the HST trains. Yeah, HSTs are fine for charters. Mark 1's running charters. Like, charters are fine. People get onto a charter train knowing and accepting the risk that they're in an old train. And that's quite reasonable. Tom has asked, why was the train not ordered to run at low speed? So we kind of went through this a couple of episodes in this series ago, didn't we? the rule book doesn't require it. So not only does the rule book not require it, but the signaller, the weather had improved. There was an understanding that there had already been issues identified, so that and trains passing. The sequence of events was such that you could understand, with the weather having cleared, that the driver and the signaller would have a sense of, right, we're just getting the passengers home now. We're kind of running the railway. We know that there have been failures here, there, and everywhere, but we reckon between here and Stonehaven it's clear. On you go. So you can understand from a kind of a behavioural, kind of a behaviour and a psychology perspective why there was no mandatory reason for them to run at caution. So you can understand why they ran in the way they did. I think we went through this in the interim. David Shepherd thinks that charter trains can still crash into other trains and thinks scrap them all. Well, the charter industry is fine. There are a small number of trains that means that the risk is substantially reduced. People, yes, they could run into other trains, but actually, I don't think it's nice to have charters running around on the rail network. Mark 1, Mark 2 coaches with a steam train at the front. It's fine. I'm fine with that. And like HSTs fall into that category. I'm fine with it. Yeah. So it's nearly been a 2-hour episode, but it hasn't been a more than 2-hour episode to please those of you who don't like it when it goes on super, super long. It's time to put close to it, I think. And the way that I want to, the way that I really want to close this off is really to actually just sort of, in fact, if I go back to, if I go here, is really to spare a moment to just think about Brett McCulloch, to think about Donald Dinny, and to think about Christopher Stutchbury, to sort of spend a moment thinking about them. The people who are impacted by this, their families, their friends, the people involved in the rescue, those who are on the train who did survive, to have a moment thinking about that. And I will see you next week. Cheerio, everyone.